Have you ever wondered why some houses cost millions while others are much cheaper, even if they look similar? Is it because of the size, the location, or the number of bedrooms? In this tutorial, we will explore real estate pricing as a practical application of data analysis. So specifically, we will use a regression model to understand what factors affect housing prices. So this project is presented by me, Saldo, Princess Shayla Visitacion, Micabelle Allison Nomo, and Rizelyn Joy, Borbe. Our focus is on using multiple linear regression to determine how different factors influence house prices. These factors include square footage, location, and number of bedrooms. So first, what is regression? Regression is a statistical method used to measure and model the relationship between variables. In this study, we are trying to understand how different factors like house size, location, and number of bedrooms affect the price of a property. Think of regression as a way of drawing the best possible line that explains how variable changes when others change. So there are two different types of regression. If we only use one factor like square footage, it's called simple linear regression. But since house prices depend on multiple factors, we use multiple linear regression. So this is the general form of a multiple linear regression model. Here, y represents the house price. The variables x1, x2, and x3 represent factors like square footage, location, and number of bedrooms. The beta values or coefficients tell us how much each factor affects the price. For example, if the coefficient for square footage is high, it means bigger houses are significantly more expensive. Also, if the location coefficient is high, it means where the house is located greatly impacts the price. And lastly, if each variable contributes differently to the final predicted value. So what makes regression powerful is that it doesn't just describe data, it also allows us to make predictions. Using the model, you can estimate the price of a house even if we haven't seen it before. Regression is widely used in real life because such as businesses use it to forecast sales, scientists use it to analyze data, and in real estate, it helps buyers and sellers make informed decisions. So in this tutorial, we will cover the following. First is a real-life housing scenario. Second, a data set of 7 housing units. Third is a regression model. And fourth is the price prediction, and lastly, the interpretation of results. So let's begin by looking at a real-life scenario where this model can be applied.
Let me introduce our scenario. Maria is a 24-year-old nurse working in Naga City, and she wants to buy her first home. She found 7 townhouse listings with known prices. Now, she is asking, if she finds another unit, how can she tell if the price is fair or not? To answer this, we consider 3 important factors that affect house prices. First, the floor area, which is the size of the house in square meters. Second, the location score, which reflects how good the location is. And third, the number of bedrooms. These are our independent variables that we will use to predict the price. The location score ranges from 1 to 10 and is based on several factors such as distance from the city center, proximity to key places like SM City Naga, road accessibility, flood risk, and neighborhood safety. For example, higher scores like 9 or 10 are in the city center, while lower scores are in more rural or less accessible areas. Here are the 7 known townhouse units Maria found. Each unit has information about its floor area, location score, number of bedrooms, and price. We will use this data to build a model that can estimate property prices. Now, Maria is looking at an 8 unit. It has floor area of 68 square meters, a location score of 8, and 3 bedrooms. And it is located near SM Naga City. However, the price is unknown. So, the question is, what should Unit 8 cost?
To answer Maria's question, we apply multiple linear regression to the 7 known units, and using the ordinary least square method, we derive the following equation. The equation is y hat is equals to negative 1,223,710 plus 34,806 times x sub 1 plus 236,452 times x sub 2 plus 422,581 times x sub 3. Now let's break down what each part means. The first number, negative 1,323,710, is our intercept. We are going to think of it as our mathematical starting point, meaning it does not mean anything on its own. Now, we have 34,806, which is the coefficient of the floor area. This means that for every additional square meter, the predicted price goes up by 34,806 pesos. We have 236,452, which is the coefficient for location score. Every point increases in location adds 236,352 pesos. This makes it the variable with the highest impact on the price. And last, we have 422,581, which is the coefficient for bedrooms. For every additional bedrooms, it adds 422,581 pesos to the predicted price. Now let us use this equation to find the predicted price on Maria's unit. Let's recall first the given data. We have floor area, which is 68 square meters. The location score are 8. Bedrooms, we have 3. And the area was near SM Naga City. So step 1, we are going with the intercept. In step 2, we multiply the floor coefficient by 68. And that equals to 2,266,808. Now step 3, we multiply the location coefficient by 8. And that equals to 1,891,616. And step 4, we apply the bedroom coefficient and we multiply it by 3. And that equals to 1,267,743. And finally, we add all the values together and we get 4,202,457. And that is the predicted fair price for Maria's unit.
What is R squared? R squared is a number between 0 and 1 that acts like a confidence showing how much of the change in house prices is actually explained by specific clues like size and location. The value of R squared always stays between 0 and 1, and a value of 0 would mean the model is essentially guessing. It explains nothing about why one house costs more than another. A value of 1 would mean the model is perfect, predicting every single price exact. When Maria looks at different townhouses in Naga City, she noticed that prices aren't all the same. Some are expensive and some are more affordable. This movement in prices is what we call variation. R squared is the tool that tells us how much of the variation we can actually explain using the information we have, such as home size or its location. For model accuracy, we can see that the model is exceptionally strong, capturing 0.969 or 96.9% of the reason why townhouse prices in Naga City vary. It shows that floor area, location, and bedrooms are the big three factors driving the market, leaving very little room for guessing or hidden costs. For Maria, this high score acts as a seal of approval, proving her price prediction is mathematically reliable and based on the real patterns of the location neighborhood. For her verdict, because because her model has 96.9% accuracy rate. She no longer has to guess if a seller is being honest. So, if the price is 4.2 million, they are charging exactly what the house is worth based on its size, location, and rooms. Maria can buy this unit with confidence knowing she is paying a standard price for Naga City. For above or much higher for 4.2 million, the seller is asking for a premium that the data doesn't support. Unless the house has hidden features Maria's model didn't count, like a swimming pool or expensive Italian marble floor, she is essentially being asked to overpay. For below 4.2 million, or if it's lower, 4.2 million, this actually happens if the seller is in a hurry to move or doesn't realize the full value of their property. This would be a bargain, or it can be a bargain for her. In this scenario, the math says that she is getting more house for less money, making it a high priority to buy. So, by using this range, she isn't just looking at a house. She's looking at a set of variables, and 4.2 million is her anchor for the entire negotiation. For takeaway, real estate prices is in market like Naga City and just random numbers. They are the result of a logical recipe that can be decoded using multiple linear regression. By analyzing core variable like floor area, location, and bedrooms, a buyer transforms from an uncertain observer into a data-driven negotiator who understands exactly what drives property value. This mathematical approach strips away the stress of home buying, providing a clear anchor price that helps identify whether a listing is a genuine bargain or an overpriced trap. And then lastly, leveraging data allows you to see past the marketing flop and make one of life's biggest financial decisions with the confidence that the numbers are firmly on our side. Applying linear regression to local listing, Maria determines that the fair market value for Unit 8 is approximately 4.2 million based on its specific size, location, and bedroom count. The model's exceptional 96.9% R-squared value proves that these three factors almost entirely dictate townhouse prices in Naga City, making her prediction highly reliable, and this data-driven strategy transforms Maria into an informed negotiator who can confidently spot a good deal and avoid overpaying.